Hmm. Hmm. Doot, 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 doot. Doot, doot. Hey, I'm streaming. How's it going? I got 3 concurrent viewers. How you guys doing? We're finishing up exam 1 material today. Let's grab a new note and do some math stuff. So last time we stated the product rule, but we hadn't done any examples of it. And the product and quotient rules are the end of what's going to be on the exam. So let's state the product rule one more time. Product rule says that if you have two functions multiplied by each other, then their derivative, or the derivative of that product, is derivative of the one times leave the other one alone, plus leave the other one alone, leave the first one alone, times derivative of the second one. Oh, I did a thing with my stylus. I think my stylus, so far it's looking pretty good. It worked immediately today. Doesn't usually do that. I just ate a bunch of Panera mac and cheese, and I'm feeling really sleepy. But I got a fresh pot of coffee to get through this. We can do it, guys. Here's the product rule. Let's try it out. Let's start by trying it on a thing that we could do without the product rule, and that'll give us a way to check that the product rule works. If I write down x squared times 1 minus 3x, this is a product of two functions. If I applied my order of operations goggles, I would need to square x and find 1 minus 3x, and then multiply those two things. And multiplying those two things would give me what f of whatever is. So that multiplication is the last step. That means the outsidemost thing, this is a product. The first rule I need to use is that this is the product rule, if I take its derivative without simplifying it. The product rule can be the one that's students have a hard time with the product rule. I think a big chunk of that is often we don't write down the fact that something is a product. The times is usually not there. You just write two things next to each other. So it's like the hardest place for your order of operations goggles to show you this is the outsidemost thing going on. Anyway, to do it without the product rule, I would FOIL that out. X squared times 1 is x squared, minus x squared times 3x is 3x cubed, and I can take the derivative of that. Derivative of that is 2x minus 3 times 3 is 9x squared. Our derivative should be 2x minus 9x squared. Let's see if the product rule is also giving us that. This is something times something. Product rule says the derivative is derivative of the first. What's the derivative of x squared? It's 2x. Times the second one. Leave the second one alone. Don't try and take the derivative yet. Plus, leave the first one alone. X squared times derivative of the second. What's the derivative of 1 minus 3x? If you said 3, you messed up because it's 0 minus 3. The 3 has a negative on it, and the negative sticks around. This is the kind of negative that students miss on the derivative a lot. What is this function? If I distribute that in, I get 2x minus 6x squared, plus this one will be negative 3x squared. That makes 2x minus 9x squared. Hey, looks like the product rule works. I haven't messed it up that bad, guys. That's the product rule. Let's do some product rule problems. If I hand you y equals 2 to the x cosine x, what's the derivative of that? Derivative of that is derivative of the first. What's the derivative of 2x? 2 to the x. It's natural log 2 times 2 to the x times leave the second part alone plus leave the first part alone times derivative of the second. Derivative of cosine is negative sine x. If you write 2 times negative sine without the parentheses, make sure you're putting a really big times here. So, I mean, if you put plus 2 to the x minus sine x without the times, you're saying to subtract those two things, not multiply them. So make sure you're making that clear. A parenthesis is the clearest way. You can put a times if you make sure your times is really big and visible. If I hand you y equals sine x natural log x, derivative of that is derivative of the first times leave the second part alone, plus leave the first part alone, times derivative of the second. Derivative of ln is 1 over x. A lot of people will write the product rule in different orders. It's just multiplication and addition. Adding doesn't care what order you put the things in. Multiplication doesn't care what order you put the things in. So you can put them in any order. I like doing it f prime g plus fg prime, because it puts one of the derivatives at the start and one of the derivatives at the end, and you can do all the busy work in between the derivatives. Like, I like that rhythm of it, where work, not work, work feels good to me. Here's an example. If I hand you y equals cosine of e to the x, how do you take the derivative of that? Try that. Do that. Pause the video, or if you're watching live, I guess pause doesn't work if you're watching live. I'm tricking you by doing this in the middle of the product rule section. This isn't a product. That doesn't mean cosine times e to the x. That means cosine of e to the x. If I was plugging in 3, I would find e to the 3, and then I would take cosine of that, and then I would be done. I never hit times at all to plug in 3. So the derivative of this is not the product rule, it's the chain rule. Derivative of cosine of something is negative sine of, leave the inside alone, times derivative of the inside is e to the x. Compare this with y equals cosine x times square root of x. Outsidemost thing is multiplication. Derivative of cosine is negative sine. Leave the second part alone. Plus leave the first part alone. Derivative of x to the 1/2 is 1/2 x to the negative 1/2. I want you to think for a second about what the first step we did on both of these problems. Both of these problems start with the word cosine, and in every, like if I look at all the derivative rules, they're always going to start with me taking the derivative of the first thing I see. Any problem where the first letters in the function are cos, I'm probably going to start my answer by writing down negative sine, but I don't want to write down negative sine until I've got myself ordered about what's going on. Like, here I'm writing down negative sine because it's derivative of the first. Here I'm writing down negative sine because the thing is a cosine. If I'm writing down negative sine before deciding this is the product rule, then I've already sort of painted myself into a corner where I'm like asking for mistakes. You need to decide that it's going to be the product rule before you start writing down the derivative of the first. Like, I'm writing down the derivative of that first thing because it is the first part of the product rule. Right, I think I made that clear. Let's try. Y equals sine of e to the x cosine of natural log x. Y prime equals derivative of sine is cosine. Hey, wait, I just did that thing I said I shouldn't have done. Don't start saying cosine until you know, like, what's going on. What's the outsidemost thing going on here according to my order of operations goggles? I would need to take natural log of 5 and then take cosine of that, and I would need to take e to the 5 and take sine of that. And once I have this number written down and I have this number written down, I multiply those two numbers and that's it, that's the answer. The last button I hit on my little calculator is the times button, or I guess equals, but the last step I'm doing is multiplying those two numbers. That says the outsidemost thing here is multiplication, and the first rule I'm thinking about is the product rule. So like, my first little note to myself is, okay, I'm doing the product rule. How's the product rule start? The product rule starts with derivative of the first. Now I'm turning my goggles to this and saying, what's the outsidemost thing here? This is sine of something. Derivative of sine of something is cosine. I'm ready to start writing. Cosine of what? Leave the inside alone. Multiply by the derivative of the inside. There, done. This was all derivative of the first. That's the first part of the product rule. Times, now I leave the second alone. Cosine ln x. Plus, leave the first part alone. This is the first part of that product rule. It's sine of e to the x. Times, now I need derivative of the second. Now I turn my order of operations goggles to this. This is cosine of something. Derivative of cosine of something is negative sine of, leave the inside alone, natural log x, times the derivative of the inside is 1 over x. Maybe I want this inside those parentheses. They're all multiplied, so the parentheses don't matter here. There's a lot of things going on in this answer, but the product rule is part of it. We did derivative of the first, left the second alone, plus left the first alone, derivative of the second. These, derivative of the first and derivative of the second, are derivatives of functions. They can be complicated. They can be the quotient rule or the chain rule or any of the rules we know. We're taking derivatives. Just whatever this thing is, whatever you have to do to take its derivative, that's what you do. Let's do product. Here's one that throws people off a lot. If I write y equals 3 to the x cosine x natural log x. This is three things multiplied together. So this is a product, but it's a triple product. And it feels like, hey, wait, I don't have a special product rule to deal with three things multiplied together. Well, that's okay, because your calculator doesn't have a special three-way multiplication button. The reason your calculator doesn't need it is you just multiply them one at a time. I could multiply these two and then multiply it by that. Or I can multiply these two and then multiply it by that. Either order works. That's the associative property. And either of those orders suggests a way to do the product rule. This is product rule here, and when it comes time to take derivative of the second, this will be another littler product rule inside that. In a second, I'm going to observe what the product rule would be for triples, because it's elegant and easy to remember, and I think it makes you smarter to be ready to write down a triple whammy product rule. But for now, let's say what we would do if we just stuck parentheses here. So it's 3 to the x times something. How would I take the derivative of that with the product rule? I would go y prime equals derivative of the first is ln 3 times 3 to the x times, leave the second alone, cosine x ln x, plus, leave the first alone, 3 to the x, times derivative of the second. Now's the place where I look at this and say, how do I take the derivative of it? And I look at it and I see it is something times something. So to take its derivative, I need to use the product rule. I go derivative of the first. Derivative of cosine x is negative sine x. Times, leave the second part alone, ln x. Plus, leave the first part alone, cosine x. Derivative of the second. Derivative of ln x is 1 over x. So here is a correct answer. You can put a box around this, you're done. Oh, hey, on the practice exam, I gave a bunch of things to take the derivatives of. I meant to add the instructions that you don't need to simplify. In general, or for these problems where you're proving you know how to take derivatives, we usually just want to get something correct written down. And that's a separate thing from working with it afterwards. So you don't need to spend time simplifying your answers on the problems that just say find the derivative. Okay, but because we want to say what is the triple whammy product rule, we're gonna say we are gonna simplify this. Let's simplify this. What do I get? I should not have. Why did I erase that? I FOIL this out. Well, there's nothing to FOIL. It's ln 3 times 3 to the x times cosine x times ln x. Plus, now this one I do FOIL out. The 3 to the x hits the first part. I get 3 to the x times negative sine x times ln x. Plus, when it hits that one, I get 3 to the x cosine x 1 over x. When I have it all distributed, I look at it and I see, hey, this is 3 things added up. This times this times this, plus this times this times this, plus this times this times this. And if I look at what those things are, I have the derivative of 3 to the x went here, derivative of cosine x went here, derivative of ln x went here. The thing is following the same pattern, like, there's a way of viewing this as an easy extension. The derivative of fg was f prime g plus fg prime. Derivative of the first, leave the second alone, leave the first alone, derivative of the second. The derivative of 3 things multiplied was, here I added 2 things together, now I'm going to add 3 things together. All 3 things are basically multiply the 3 functions, but everybody gets a turn being the derivative to one. F prime here, g prime here, h prime here. Derivative of the first, leave the second alone, leave the third alone. Leave the first alone, derivative of the second, leave the third alone. Leave the first alone, leave the second alone, derivative of the second. We're doing all 3 possible products. We're adding up all 3 possible products where one of them gets a turn being derivative. And this pattern continues. If I had a quadruple product, it would be, everybody takes a turn. Let's try a quadruple product. Can I come up with 4 functions? If I write down h of x is cosine x times sine x times 3 to the x times the cube root of x. Then the derivative of this is derivative of the first, leave the others alone, so negative sine x, 3 to the x, cube root x, plus, now I'm going to do the second one. So cosine x is left alone, derivative of sine x is negative cosine x, derivative of, or leave 3 to the x alone, leave cube root of x alone. I'll write it as x to the 1/3, so I have something to stare at when I'm taking its derivative. Plus, leave the first one alone, leave the second one alone. Derivative of the third is ln 3 times 3 to the x, leave the third one alone, fourth one alone. Plus, leave the first one alone, leave the second one alone, leave the third one alone. Derivative of the last is 1/3 x to the negative 2/3. Everybody took a turn. And there's the derivative. 4 things added up, each of which is a quadruple product of all of the original things, except one guy got derivative, and everybody took a turn being the guy who got derivative. That's the product rule. Let's try mixing it up a little. Let's try doing y equals 4 sine of the square root of x e to the x. How do I take the derivative of that? I guess the outsidemost thing is a constant out front. Constant out front stays out front. That one's easy. Next most inside thing, the constant is out front of sine of something. How do I take the derivative of sine of something? That's the chain rule. Derivative of sine something is cosine something. Cosine what? Cosine leave the inside alone. Times, now I need to take the derivative of the inside. So now I turn my goggles to this. How do I take the derivative of this? This thing is something times something. So it's going to be the product rule to take the derivative of the inside. This is a product rule inside of a chain rule. How do I do that product rule? I need derivative of the first. Derivative of x to the 1/2 is 1/2 x to the negative 1/2 times leave the second alone, e to the x, plus leave the first alone, x to the 1/2, times derivative of the second is e to the x. Here's our answer, except I need parentheses here. This is all derivative of the inside. The chain rule wants us to multiply that as, that's all getting multiplied by. Derivative of the outside, leaving the inside alone. Product rule. Should we do more of this? Yeah, let's do a pretty gross run. Let's do f of x equals e to the x squared cosine x times cosine of x log x. This is a pretty bad one. Hey, heads up, we're doing some really hard ones in class. The goal is to do things that are harder in class than you'll need to do on the homework or the exams. So we want to emphasize, like, you want to have seen things harder. What's the outsidemost thing going on? The outsidemost thing is this multiplication. This is e to the something times cosine something. I can look at this function and say it is something times something at the outsidemost level. So the outsidemost thing I need to be doing is the product rule. It starts with derivative of the first. I need the derivative of e to the this. How do I take the derivative of e to the something? Derivative of e to the anything is e to the that thing, leave the inside alone, times the derivative of the inside. So now I'm turning my goggles to this and saying, how do I take the derivative of this? Well, this thing is at its outsidemost level, something times something. So taking the derivative of this is going to be a product rule. At this moment, the pages that my fingers are keeping track of is I'm about to do the product rule inside the chain rule inside the product rule. The hard thing going on is keeping track of where you are in the middle of a long sequence of jobs to get done. Derivative of x squared cosine x is 2x is derivative of the first, leave the second alone, cosine x, plus leave the first alone, x squared, derivative of cosine x is negative sine x. There. That finishes the derivative of the inside, which means we're finished with derivative of the first, which means I'm back in the outsidemost product rule. I did derivative of the first. Times what? Times leave the second part alone. Cosine of x ln x. Plus, now leave the first part alone. E to the x squared cosine x. Times derivative of the second. Now it's time to look at this thing and say, what is his derivative? Well, this is cosine something. Derivative of cosine something is negative sine. Negative sine what? Negative sine, leave the inside alone. Ln x. Times, now multiply by the derivative of the inside from the chain rule. That got written sloppy. This is x ln x. Now I'm looking at the inside here and saying, how do I take the derivative of that? Derivative of x log x is a product rule. This is something times something at its outsidemost level. Either of those things is a constant. I can't use a constant multiple rule here. Derivative of x log x will be product rule. I need derivative of the first. Derivative of x is 1. Leave the second alone, ln x. Plus leave the first alone as x. Derivative of ln x is 1 over x. I might wrap all this in parentheses so the minus sign doesn't look like subtraction. But this is it. There we go. Man, this is rough. There's a thing we're thinking about in these big long ones, which is that when you do these things, everything in sight should have had its derivative taken at some point. This ln x, did it get derivative? Yeah, it was right here. This x squared, did it get derivative? Yeah, it was right here. How about this cosine? It's over there as negative sine. Every piece of it has its derivative appear somewhere. Even like this multiplication became this product rule. This multiplication became this product rule. This multiplication became this whole thing product rule. Every piece of it did get derivative. Usually when, or I don't know if this is usually, but sometimes when these go wrong, you like have a feeling you forgot something. You can often go through and say, did I actually get every derivative taken at some point? Yeah, product rule. Let's do one more example and then we'll say the quotient rule. If I hand you g of x is natural log of 15 minus e to the cube root of 1 minus cosine of pi squared. How do I take the derivative of that? Well, the outsidemost thing is a natural log. Derivative of natural log something is 1 over that thing, leave the inside alone. 15 minus e to the cube root, 1 minus cosine pi squared. Oops. Okay, times, now I go to the derivative of the inside. Now I'm turning my gaze to this part and saying, how do I take the derivative of that? Well, the 15 is, that goes away. I get 0 minus. I like writing that 0 because it makes me remember to put that minus. Minus, what's the derivative of e to the something? Derivative of e to the anything is e to the, leave the inside alone. Cube root 1 minus cosine pi squared. Times, now I need the derivative of the inside. Now it's time for me to turn my gaze to this thing and say, how do I take the derivative of that? It's helpful to remember it's that stuff to the 1/3 I'm looking at. A cube root is a power of 1/3. Derivative of stuff to the 1/3 is 1/3 stuff, leave the inside alone, times the derivative of the inside. To a power of negative 2/3. Then times the derivative of the inside. How do I take the derivative of the inside? Again, I have one of these constants whose derivative is 0, but it's a place where I might want to write the 0, because it helps me remember that that minus is stuck on this cosine. I need it there. 0 minus, what's the derivative of cosine something? Derivative of cosine something is negative sine of that thing. So I get 0 plus sine of pi squared times the derivative of the inside. What's the derivative of pi squared? Maybe you're already ahead of this, but this is something squared. Derivative of something squared is 2 times that thing times the derivative of the inside. What's the derivative of pi? Well, pi is a number, and its derivative is 0. So I get that. So, wait, hold on. This stuff is all being multiplied by 0. So this is 0 plus 0. Makes this whole thing is 0. Is being multiplied by, all of this is being multiplied by 0. And all of this is getting multiplied by 0. The derivative is 0? And then you go, oh yeah, wait a minute. Not only is pi a number, this whole thing is a big complicated number. Cosine of, like, pi squared is a number. Cosine of that, 1 minus that, cube root of that, e to that, 15 minus that, natural log of that. This is all some constant. The derivative of any constant is 0. So the answer is 0. We could have noticed that at the start. If we didn't notice that at the start, we've got ways to notice it at the end. Like, it's reasonable to not inspect the insides of these things until you get to the time that you need their derivatives. In the end, the derivative of this is 0. So, weird. Again, you don't need to simplify your answers as long as you've got this times 0. Like, putting a box around this is fine. It's a very complicated way of writing 0, but it is still 0. Unless I told you to simplify. I'm not taking off for not simplifying. Crud. I'll be right back. I gotta go visit the little mathematician's room. Hey, I'm back, everybody. Did I mute this? Hey, I'm back, everybody. How's it going? I can't believe I said the little mathematician's room. I got this weird thing where I'm in public, but I feel like I'm in private. I'm saying all the dumb things I would say when I'm in a room by myself, but people can hear me. I hate this. Let's talk about the quotient rule. Before I say what the quotient rule is, I want to observe that we don't really need it. If I needed the derivative of y equals, let's say, sine x over 3 to the x, I have the option of rewriting this. I can rewrite that as sine x times the reciprocal of 3 to the x, means 3 to the x to the negative 1. And now I can do it using the product rule and the chain rule. I don't need a separate rule just for fractions. We're going to learn the separate rule just for fractions, but if you're a person who really hates memorizing, hey, it's worth noting that you have a way of getting around this. This one's not that hard to memorize, especially after the product rule, which you have to memorize anyway. The derivative of this would be derivative of the first, cosine x, times, leave the second part alone, 3 to the x to the negative 1, plus leave the first part alone, sine x, times derivative of the second is negative 1 stuffed to the negative 2, times derivative of the inside is ln 3 to the x. So you can do these derivatives without the quotient rule because of the stuff that we're going to be doing in chapter 4. You really want, if you want this simplified, you probably should have just done the quotient rule. Like cleaning this up will largely amount to just do the quotient rule, and that's the cleaned up version of this. Let's clean this one up so that we can see what the quotient rule is going to be. If I turn both of these parts of the answers back into fractions again, this looks like cosine x over 3 to the x plus sine x times ln 3 times 3 to the x over, that power of negative 2 means over this thing squared, so over 3 to the x squared. I want to, oh, and I lost the negative 1. I want a common denominator. The common denominator between these two fractions is going to be 3 to the x squared. So I'm going to stick an extra 3 to the x on top and bottom of this. And now I have a common denominator. I can write this as 3 to the x cosine x minus I want to put that in the other order. I should have put the 3 to the x after. I'm going to write that as cosine x what? Oh, I switched to the other window? Oh, this one crashed. I think my stylus has been working for 45 minutes straight. This is great. Oh no, I totally lost that problem. Well, why don't I just tell you what the quotient rule is? Actually, why don't I start from scratch doing the quotient rule? I want to know what the derivative of f of x over g of x is. The way this works is f of x over g of x is f of x times the reciprocal of g of x, that's g of x to the negative 1. The derivative then is going to be product rule, derivative of the first, leave the second part alone, plus leave the first part alone, derivative of the second is negative 1 g to the negative 2 times the derivative of the inside is g prime. I write this like fractions, the way I did the other one. I have f over g minus fg prime over g squared. I want a common denominator. I stick an extra g on top and bottom of the first fraction to give them a common denominator. I get f prime g minus fg prime all over g squared. This is the quotient rule. The derivative of a fraction, something over something, is a fraction. The new bottom is the old bottom squared, and the new top is derivative of the top, leave the bottom alone, minus leave the top alone, derivative of the bottom. The top looks a lot like the product rule, but it has a minus instead of a plus. And there's this whole bottom squared part that isn't there for the product rule. People forget that bottom is there more often than you would think. Like, it's the worst way to get a problem wrong is forgetting the bottom when you got the whole top right. Some teachers don't like the fact that this looks like the product rule, and they will present the product rule in a completely different order just so that these are not or stored so that they don't look similar to, I guess, prevent confusion. I find it hard to remember things, and I would way rather remember them in almost the same way, because then it's just a little bit more to remember. The quotient rule is a little bit different from the product rule. It's a minus, and there's this whole bottom thing squared. Let's try out the quotient rule. Let's start with a simple version. Actually, let's do an applied problem. If I write down y equals, let's make it sine x over x squared. And let's find y prime of 1 and use that to, let's find y prime of 1 and use that to write the tangent line to the function at x equals 1. We did the tangent line stuff back in chapter 2 when we were computing derivatives by hand without using the shortcut rules. And we still know how to do it. We do it in the same way. It's just now we are able to compute y prime of 1 without finding a y of 1.001 minus y of 1. That was how we were estimating the derivative. Now we can compute the derivative exactly directly. Let's find y prime. Y prime is derivative of the top, cosine x, times, leave the bottom alone, x squared, plus, leave the top alone, sine x, times derivative of the bottom, 2x, all over bottom squared, x squared, squared. There's the derivative. What's y prime of 1? Y prime of 1 is going to be cosine 1 times 1 squared plus sine of 1 times 2 times 1. All over the bottom squared is 1 squared squared. 1 squared squared is just 1. Dividing by 1 doesn't do anything. I don't need that bottom. This number is 1. That number is 1. I'm getting up with cosine 1 plus 2 times sine 1. You might ask yourself, does that simplify? Well, I mean, you can get digits on it, but it's not going to be a nice number. Sine and cosine are nice at like pi and multiples of pi. At 1, it's going to be some gross pi-like infinitely long digits. Actually, let's get some digits on this, because that'll be what we want to try and graph this thing. Dear calculator, what's cosine 1 plus 2 sine 1? It's 2.223. So we found y prime. We found y prime of 1. We want to write the equation of the tangent line to that function at x equals 1. The tangent line is one of those things that you can remember as, how did we write it? New y is approximately old y plus slope times the change in x. In this case, that's going to be y equals y value plus the slope, x minus the x value. This is the point slope form of a line. The x value we know is 1. The slope is the derivative we just found is 2.223. The y value, this is the old y value, is y at 1. We never found that. That's going to be sine 1 over 1. squared, that's sine 1. That's another thing I can get digits on. The calculator, what's sine of 1? I gotta use my mouse for this. What's sine of 1? It's 0.8414. So my line is y equals 0.841 plus 2.223 times x minus 1. We can simplify that into point slope form. I'm probably not going to ask you to do that. I think the practice exam has some problems I stole from the homework that do ask you to do that, but mostly that's not a thing I care about. If we're doing... I pulled out my physical calculator to graph it. That's not going to work. Let's graph that. If we did this right, it will look like a tangent line. Sine x over x squared is the curve, and the thing that's supposed to be the tangent line is 0.841 plus 2.223 times x minus 1. Let's graph these. Oh, that seems wrong. You know what I did? I did the exact thing I said people do. The quotient rule has a minus, not a plus. Derivative at the top, leave the bottom alone, minus leave the top alone, derivative at the bottom. So this should have been a minus. So this should have been cosine minus 2 sine 1, which, according to my calculator, second enter, that'll retype it in. I just need to change the plus to a minus. The slope should have been negative 1.14. Dang. Minus 1.143. Let's graph that one. That looks better. Let's zoom in a little bit. I love these tangent line problems because it's one of these places where you do a lot of computing derivatives and you don't ever get a sense that they're correct. This graph at x equals 1 is the place where, here's x equals 1, here's the place where it's just grazing the curve. It looks like it's just grazing the curve. That sure is what a tangent line looks like. The last one was just going through the curve, was not a tangent line. You can tell when it's right. Cool. That's the quotient rule. Let's do some more examples of this. Let's try y equals 3x squared minus 6 over x. Let's take the derivative of that. This is written as a quotient. The quotient rule is the most obvious rule to use. Quotient rule says derivative of the top. What's the derivative of 3x squared minus 6? Why, it is 6x minus 0 times what happens next? Leave the bottom alone. Minus, it's a minus, not a plus. Minus, leave the top alone. 3x squared minus 6 times derivative of the bottom is 1. All over the bottom squared. If they told me to simplify it, I could, but they didn't, so I'm not gonna. The point is to be able to prove you know the quotient rule and junk. Right now, there will be times to simplify it. We're not at those times. Excuse me. Let's try. Oh, the reason I did this problem was to show off, hey, wait a minute, don't forget, you knew how to do this without the quotient rule. The quotient rule was totally overkill. We were doing problems like this back when we only had the power rule, which might have been yesterday. We did it by splitting up the fraction. This is 3x squared over x minus 6 over x That's 3x minus 6x to the negative 1. I can take the derivative of that without a quotient rule. It's 3 minus plus 6x to the, subtract 1, negative 2. This, I guess, will simplify into that. Sure, I can believe that. It's not immediately obvious that it is. I didn't want to do the whole simplifying thing. This one's not that bad to simplify, but if it got a little bit worse, it wouldn't be worth it. You can check that it actually does equal by, for example, plugging in a number. Plug in 3 here, plug in 3 here. It would take a miracle for these not to be the same, but if you plug in 3, they are the same. If they are the same, they're the same when you plug in any point. And, you know, picking a random number, they probably won't be the same unless, yeah. Let's do some messier quotient rule problems. Let's do h of x is the cube root of x squared sine x over x minus 1. Gross. I see this quotient, and I might think to start doing the quotient rule, but it's not time for that because my goggles show me that after I divide, that's not the answer. If I'm plugging in 3, I want 3 squared sine 3, divide that by 3 minus 1, that's not the end. Dividing wasn't the answer. After that, I gotta take the cube root. The outsidemost thing is that cube root. This is the cube root of something. That means that's the outsidemost rule I gotta do. The derivative of something to the 1/3 is 1/3. Something to the 1/3 minus 1 is negative 2/3. What goes in here? I know the quotient rule, but it's not time for the quotient rule. This is leave the inside alone time. X squared sine x, x minus 1. The time for the quotient rule is outside. Now is the time that I look at the inside and write its derivative out here. Now, this is the thing that's a quotient. This is the time to use the quotient rule. How's the quotient rule go? Quotient rule starts with derivative at the top. So now I look here and say, how do I take the derivative of this thing? This thing's a product. The outsidemost thing is this is x squared times sine x is what that is. So now I need to use the product rule. Product rule says start with the derivative of the first. So now I look here. How do I take the derivative of x squared? The derivative of x squared, I know. It is 2x. Looking at this thing, the first part of the fraction is 2x, and I could probably just write down 2x and be correct so far, but I don't want to write this 2x down until I've thought, first I'm doing the quotient rule, then I'm doing the product rule. Now I write down the 2x, because when I'm done doing that, I need to say, where was I? I was in the middle of the product rule. I took the derivative of the x squared. Now I need to leave the sine x alone. Plus, now I need to leave the first part alone, x squared, times now I need the derivative of sine x. It is cosine x. That, I'm finished with the product rule. Wait, why was I doing the product rule? Product rule was, the product was the top of the fraction. I was doing derivative of the top. I'm done with derivative of the top. What comes next in the quotient rule? It goes derivative of the top times, leave the bottom alone, plus, no, not plus. That's how I messed up last time. It's minus for the quotient rule. Minus, leave the top alone, x squared sine x, derivative of the bottom. Derivative of the bottom is 1. All over, bottom squared. Whew. So this is chain, then quotient, then product. Rough. The ones on the exam won't usually have 3 of the rules stacked up on top of each other, but there's a good chance of seeing 2 of them. Get your practice in. Do a bunch of derivatives. Do what's in the homework. The homework has them 2 at a time. And, you know, do your best. Is anyone watching this? Nobody's watching this. Okay. Yeah, that's it. We did the quotient rule. I guess it's time to do the practice exam. Let's do the practice exam. My advice is take the practice exam. Like, give yourself a couple hours before you watch me do the practice exam. You learn way more from seeing what you did wrong, or, I mean, put yourself face to face with the piece of paper and see how it goes. Let the practice exam be the start of your studying. Use it to say, hey, this is what I didn't understand. I'm going to take another look at those homeworks. I need to log back into Blackboard. Don't need you. Blackboard login. 122. Course content. Practice exam. H prime of 60 is what's the slope of the tangent line at 60. Here's 60. How do I find the slope of the tangent line? I hold up a ruler to the paper, or, probably like not a ruler, but whatever I have handy that's a straight line. I hold it up so that it's at the same angle as the curve, and I draw this line, and I try and estimate the slope of the line. I kind of went off the rails there. I'll use a point before my line went nuts. H prime of 60 is that slope is about, what are these points? This is like 105, 100. What's this point? That's like 0, 420. 420. The slope is difference of the y's, 420 minus 100, over difference of the x's, 0 minus 105. This is 320 over 105. It's very close to 3. .05. So I'd say h prime of 60 is about 3. If you've got 3.1 or 2.8 or whatever, like this is an estimate. Don't feel weird if you got different points than I did and got slightly different numbers than I did. But your answer should be pretty close to, -3, dang it. Right? Yeah, 0 minus 105 makes -105, makes this a -3. Derivative's about -3. If you got -2.5 or -3.5, don't sweat it. If you got -10, something probably went wrong. You should definitely have gotten a negative, because the thing is decreasing here. You should be able to check some about your answers pretty easily. The fact that it's decreasing should be clear. You might be thinking in terms of rise over run. Well, this is about down 2 over 2, should be close to 1. That rise over run doesn't work so good because these units are all goofy. These are 20s and these are 100s, so that down 1 over 1 doesn't really make sense the way it would for if the axes were normal. Let's grab number 2. Oh, I love this question. Here's a function. Put these values in order from least to greatest. This is a derivative, a slope. Almost everything in sight is a slope. 1 isn't obviously a slope, but wait a minute, this is the line y equals x. 1 is the slope of this line. Second derivative is the only one that's not a slope. But hey, check out, let's think about that second derivative first. This graph, that function, is concave down, right? This is Frowney type. So f double prime of a is negative. And it's the only negative number in this list. All these slopes are positive, and this number is 0. So g, being the only negative number, has to be the least. Then 0, f, is the next least. And now everything else is positive, so I just got to figure out what order do these things go in. I got f prime of a is this slope. I got f prime of b is this slope. I got f prime of c is this slope, is answer C. D is the slope from A to B, so that's this slope. E is 1 is this slope. I want these in order from least to greatest. They're all positive, so the flattest one will be the least positive slope. That's going to be C. The graph is getting flatter and flatter over time, so it's at its flattest at C. Then B. Then these guys are all steeper than B. A is the steepest. That leaves D and E. E must be steeper because it caught up with and passed line E. So it's D, E, A. So I'm getting the answer to this would be G, F, C, B, D, E, A. And that's the order. If this was on the test, how do you grade this? This is a thing that's a huge pain in the ass to grade. I guess you don't need to care about it, but the way I grade things like this are there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21 pairs of letters. I count of those 21, how many did you put in the right order? So if you have D left of E, that is one of the 21 points you could get here. And then it's scaled out of 11 or whatever. It's a huge pain to grade. I'm glad there's not that many of you guys. Let's estimate f prime of 2. Copy. Paste. If I had an equation, I would be thinking in terms of trying to get f of 2.01 minus f of 2 divided by 2.01 minus 2. That doesn't make sense here because I can't plug in 2.01. Instead of picking a number that's very close, I just say, well, what's the closest number I can get? Among all the x values that I know the f value for, I can plug in 0 and 0.5 and 1 and 1.5 and 2 and 2.5. What's the closest to 2? Well, 1.5 and 2.5 are tied for closest to 2. Which one should I use? They didn't give me instructions. I'm going to use both and split the difference. I'm going to take f of 2.5 minus f of 2 divided by 2.5 minus 2. I'm going to take f of 1.5 minus f of 2 over 1.5 minus 2. And then I'm going to split the difference between these two approximations. This is 7.25 minus 5 over 0.5. 2.25 over 0.5 is, that's double for, I think that's 4.5. This one is, what's 3.25 minus 5 over negative 0.5 is 1.75 negative over negative 0.5. The negatives cancel. Double that is 3.5. So I got the answers about 4.5 one way. I got it's about 3.5 the other way. Split the difference, I would say f prime of 2 is about 4 is the average of those. 4.5 and 3.5 over 2, the average of those is 4. I don't need to work it out to say I know the average is, uh-oh. This thing's crashing all the time. Oh man, I lost the entire practice exam so far. Well, I guess it's nice that I made a video of it. That was number 3. It's about 4. Here's two functions. One of these is the derivative of the other. This is like that matching thing, but... which one is the derivative? Well, let's see. This function increases, then decreases. So its derivative will be positive, then negative. Is this function positive, then negative? No, that function is always positive. It stays above the x-axis forever. What is up with this function? This function also increases, then decreases. Its derivative will be positive, then negative. Is this function positive than negative? It is. So this is the derivative, this is the original. A is the derivative of b. What am I seeing that makes me give that answer? B is always positive. And A isn't always increasing. So B isn't the derivative of A. Other things I might make mention of, this function has a critical point here where it switches from increasing to decreasing. That corresponds with here's the place where it switches from being positive to being negative. This graph is concave up, then concave down. This graph is increasing, then decreasing. Those are other signs that they match up. As opposed to this graph is always concave down, its derivative should be always decreasing. This is not always decreasing. B can't be the derivative of A, because A is always concave down and B is not always decreasing. There's a lot of things you can say, you just need one good reason to know that one is correct and the other one's not. There's another good question. Man, I'm burning all my good questions on the practice exam. I like this question because it's not like any homework question, but it's still completely fair. It's just a good, do you understand the words we use in this class? G of t is the height of a person whose age is t. And we're asking about the derivative of this function. When is it positive? When is it negative? When is it 0? G prime of 40, is that positive, negative, or 0? That means I answer that question by thinking, is a person who is 40, is their height increasing, or decreasing, or constant? G prime of 40 is probably 0. A 40-year-old isn't growing or shrinking in height, usually. How about G prime of 10? Is a 10-year-old growing or shrinking, or neither? A 10-year-old is growing. So G prime of 10 should be positive. 10-year-olds are still growing. How about G prime of 80? Some 80-year-olds shrink, not all of them. It's 0 or negative. Depending on whether the person is shrinking in their age. I'll take either answer. If you say they're shrinking, use the word shrinking. Anyway, I just like questions like this that are just about, do you know what the words mean? This is relying on you to know some facts about human beings, that they grow and shrink and whatever. What's up with number 6? Ooh, this is a good one too. Listen to me, I'm in love with my test. I want to label these things positive, negative, 0. Copy. Paste. It's a good question because it asks you to think about a lot of stuff, but it doesn't take like any time at all. Is f positive or negative or 0 at these 4 points? Well, I'm asking, what is f of a? I don't have numbers on the y-axis to read off what the number is, but I can see I'm below the x-axis. This is going to be a negative number. You're above, above, above. So f of b is some positive number. F of c is a positive number. F of d is a positive number. Right? That's f. How do I know what's going on with f prime? The derivative is its sign depends on whether the function is increasing or decreasing. We are increasing, then decreasing, then neither. So we are increasing is positive derivative, increasing is positive derivative, decreasing is a negative derivative, horizontal is a 0 derivative. What's going on with the second derivative? This is asking about concavity. Are we concave up or concave down? This is smiley type of curve, so that's concave up, positive. This one is a frowny type curve. It's bending this way. That's a negative. D is completely straight line, right? So that's the one that is neither concave up nor concave down. That one should be a 0. C, I think C is supposed to be at a point of inflection. We are concave up here, and we are concave down here, and this looks like it's maybe the place where it exactly switches over. I think this question was intending the second derivative to be 0 here, but I wouldn't take off if you thought it was one way or the other. Seeing where an inflection point happens is hard with your eyeballs, so I wouldn't have graded this one if it was on the test, but I think I would put the answer 0 here. The homework is really finicky about its estimates in a way that I am not for things where you're looking at a graph and reading stuff off. When I'm asking you to estimate f of 1.9 or whatever, that's a thing where, you can be precise. I mean, stuff that you can use a calculator for. I can ask for some digits of accuracy. For graphs, I don't want to. Sorry that the homework is so finicky. I quit using that homework in my regular classes. We're doing it now because trying to make up for what's being lost by not meeting in person. Here's a point. That's not a point. Here's a problem. To produce 250 items, the total cost is 4,500. The marginal cost is 14. Estimate how much it will cost to produce 258 items. This is one of many problems that can be done by new y value is approximately an old y value plus a derivative times a change in x, right? Here I want to know what is C of 258. That is a new y value. That is a value that is not given to me by the problem. It's approximately the y value that I know, C of 250, plus C prime of 250 is the derivative at that point that I know, times the change in x. How many items did you change? That's going to be the 258, the new value minus the old value. Making 250 items cost 4,500. Extra items cost about 14 each, and you want 8 extra items. 8 times 14 is 112. That's 4612. That's my approximation of the cost to make 258 items. What else we got? Here's a population. P of t is measured in thousands. It's P of t 1,000 bacteria at time t hours after the beginning of an experiment. Oh, this is the exact same deal as before, where I know what's happening at 10, I know the derivative at 10, predict what's happening at this value near 10. Our new p is about the old p plus the rate of change times the change in t. P of 10.5 is probably about P of 10 plus P prime of 10 times 10.5 minus 10. Our value at 10 was 25. The derivative was 0.4. The difference is 0.5. Half of 0.4 is 0.2. It's 25.2. Make a prediction for P of 10.5 is probably 25.2 thousand bacteria if I wanted units. This one's not particularly saying it wants units. Sort of, I care about, well, what? I don't care. Nine. Approximate this to 2 decimal places with a difference quotient and a calculator. So I need to know that my answer is 2 decimal places correct. So this is a place where I want to repeat this until I know for certain that 2 of these decimal places are correct. Notice that we can get this derivative without using a difference quotient. We've learned the shortcuts of differentiation. I can take q prime of x, it's 1/2 something to the negative 1/2, times the derivative of the inside. So q prime of 1 is 1/2 3 times 1 plus 1 to the negative 1/2 times 3. I can stick that in a calculator and get digits directly. This is not what this problem is telling us to do. This is saying use a difference quotient. This is saying do it the way you did in chapter 2 with the definition. So I need what is q of some number close to 1. Let's go with 1.001 minus q of 1 divided by 1.001 minus 1. This is the square root of triple that plus 1, 3 times 1.001 plus 1, minus what is q of 1? Q of 1 I can do. Square root of 3 times 1 plus 1 is 4. That number is 2. Is the square root of 4. Dear calculator, what is 3 times 1.001 plus 1? Take the square root of that. Subtract 4. Divide by 0.001. I get negative. This doesn't seem right. Oh, I subtracted 4 instead of subtracting 2. Let's try this again. 3 times 1.001 plus 1. Square root of that. Subtract 2. Divide that by 0.001. I'm getting an answer of 0.74985. I need 2 decimal places accurate. I don't know if these 2 decimal places are accurate. Looks like it might be 0.75. Like this is pretty close to 0.75. Let's do this again with a couple more zeros and see if those first 2 decimal places are changing. Well, the square root of 3 times 1.00001 plus 1 minus 2. Divide that by 0.00001. What are we going to get? This is one of these places where if I had typed it all out, I could probably just hit second enter a couple times and reuse all the typing. 1.00001 plus 1. Take the square root of that. Subtract 2. Divide that by 0.001. I get I divided by the wrong number. I need to divide by another 2 decimal places. Well, I need to move the decimal place 2 more times because I divided by 0.001 instead of 0.00001. I get 0.74999. It looks like the first 2 decimal places round to 0.75. Q prime of 1 is about 0.75. I think it's exactly 0.75. I could check that out using this, but that's not what this problem's asking us to do. When the problem says to use a difference quotient, use a difference quotient. That's what the question's about. If you want to check your answer with the other thing, go for it. But when the problem says to do the thing, do what the problem says if you want the credit. Don't save. Copy. Give the difference quotient approximation to 2 decimal places of this derivative. So here's another approximate f prime of 10. Make sure you have 2 decimal places of accuracy. Oh, I screwed. This problem is bad. I apologize if you did this problem. F prime of 10 is massive. This is like... It's like in the millions, probably. I should have picked a smaller number. Let's approximate f prime of 3. Let's do f prime of 3. It's probably not that bad. And I changed the function. I didn't notice that made the number busted. To get 2 decimal places of accuracy would be crazy for 10. I'm sorry about that. Hey, if that happens on the exam, give me a heads up. F prime of 3 is about, let's do f of 3.0001 minus f of 3 divided by 0.0001. What is this? This is e to the 3.0001 minus 3.0001. minus e to the 3 minus 3. Divide all that by 0.0001. I'm going to be smart and type this entire numerator into my calculator so I can reuse that typing. And I'm going to be even extra smart. Okay, the first thing is e to the 3.0001 minus 3.0001. Oh, I didn't do the extra smart thing I was going to do. After the 0001, I want to insert some zeros that don't do anything to make it easier for me to move the 1 over as I do this. Like I can just type 01 and not have to use the insert button. If you're not following why I did that, it doesn't really matter. Minus e to the 3 minus 3. Close that parenthesis. So that's the top of the fraction. Divide that by 0.0001. I'm getting an answer of 19.0865. Now let's try it with even more accuracy. Let's try f prime of 3.00001. Second enter, second enter. Oh, 1. Divide that by 0.00001, and I get 19.085. 6, dot, dot, dot. The 0.08 part is staying the same. It looks like these digits are still figuring themselves out, but it looks like f prime of 3, the first 2 decimal places should be 19.08. Again, the instructions were to use the difference quotient approximation. This practice exam didn't have any problems where I give you a delta x, but that seems like the kind of thing that's fair to do. Instead of saying make sure you have decimal places of accuracy, I might say use delta x as 0.03. So you have to use 3.03 as the number you plug in. Cool. And then the rest of this is all find derivatives of things. On your exam, I will give you space. I was just... Let's do this. Let's grab a few of these. Derivative of the first one. T prime of x is 4x cubed minus 6x squared minus 5 plus 0. Don't need to write the plus 0, but not a bad idea to write it. H of x, I can use the product rule on. If I use the product rule, h prime of x is derivative of the first times leave the second part alone plus leave the first part alone, x cubed, times derivative of the second is 2. Didn't say to simplify, don't need to simplify. I'll probably emphasize on, I meant to write, hey, you don't need to simplify. I can simplify the original. Hey, this is one where I didn't need the quote product rule. Because if I rewrite it like this, it's really easy to say the derivative of that function is, 8x cubed minus 3x squared. I like putting these problems where you can notice a simpler way to do it, but you can also just do it by brute force. C is a quotient. Derivative with the quotient rule. Quotient rule says derivative of the top, leave the bottom alone, minus leave the top alone, derivative of the bottom, all over bottom squared. D, derivative of this. This is cosine something. Derivative of cosine something is negative sine of something. Negative sine of what? Of leave the inside alone. Times now the derivative of the inside. That inside is all stuffed to the 1/2. The derivative of that will be 1/2 stuffed to the negative 1/2. What is being raised to the negative 1/2? Leaving the inside alone. Times now the derivative of the inside of that. This is chain. Derivative of 1 minus log x is 0 minus 1 over x. Make sure the negative is on the 1 over x. This one's pretty easy. Derivative of 2 to the x is log 2 to the x, minus derivative of x squared is 2x, minus x e to the x, this needs product rule. It might be good to think of this as, that didn't work. It might be good to think of this as minus x times e to the x. The minus is on the whole thing, needs to hit everything. Or if I think of the minus as part of the x, then the fact that it'll needs to hit everything will be baked into the product rule. There's like different ways of thinking about it, but in the end everything's going to be negative. Derivative of negative x is negative 1, leave the second part alone, e to the x, plus leave the first part alone, negative x. Derivative of e to the x is e to the x. As long as both of these things have minuses on them, you're okay. Plus, now I need the derivative of this, which is also a product rule problem. This is x squared times cosine x. Derivative of the first times leave the second part alone. Plus leave the first part alone, derivative of the second, minus sine of 2x, times the derivative of the inside, derivative of 2x is 2. There's e. F. What's the derivative of this thing? This one's a triple product. You don't need to know the triple whammy product rule. If you stick parentheses here, you can just use product rule inside product rule. But I spent all that time teaching the triple whammy product rule, I might as well use it. Derivative of a triple product is a triple sum. Derivative of the first, leave the second alone, leave the third alone. Plus leave the first alone. Derivative of the second, leave the third alone. Plus leave the first alone, leave the second alone. Derivative of the third. Derivative of the third doesn't do anything, but I write it there. There's F. Let's find some second derivatives. F prime of x is, derivative of this thing is 1 minus 1 over x. To take his derivative, I'm going to want to think of him as x to the negative 1. You can use the quotient rule, but it's way overkill to use the quotient rule on 1 over x. Second derivative is 0. Derivative of minus x to the negative 1 is plus x to the negative 2. The negative 1 hits the minus outside. B. G prime of x is derivative of 2 to the x is ln 2 times 2 to the x, minus derivative of 2x is 2, minus derivative of 4 is 0. Second derivative. ln 2 is a constant out front. Derivative of 2 to the x is another ln 2 shows up out front, so it's ln 2 squared, times 2 to the x. Minus that part goes away, I just have this left. Cool. And last one. This is another combining things from chapters 2 and 3 problem. Where's my copier? There it is. Find the derivative of this function, use that to find the derivative at 2, use that to estimate f of 2.013. This is going to be one of those new y value, old y values. Hey, I think this new y, old y stuff is a big deal. And it's likely to be pretty heavy in this exam. Like, I think that is the most important thing we've seen on this exam. It was 3 problems of the practice exam. You can expect something comparable. Let's find f prime of x. So, okay, this is very similar to something that could have been in the first half of the exam. In the first half of the exam, it would have said use the difference quotient. This isn't. This is saying just find the derivative. Derivative of that function is 2x minus 1. F prime of 2, then, is 2 times 2 minus 1. It's 4 minus 1 is 3. F prime of 2 is 3. If I had found f of 2.001 minus f of 2 divided by 0.001, it would have been very close to 3. Like, the thing I keep wanting to emphasize is the old way of finding the derivatives is still giving you the same thing, because the derivative is the derivative either way. Anyway, I want to estimate f of 2.013. That's a new y is about the old y plus the derivative times the change in x. So f of 2.013 should be about f of 2 plus f prime of 2 times 2.013 minus 2. What's f of 2? F of 2 is 2 squared minus 2 is 4 minus 2 is 2. What's f prime of 2? I found that it was 3. What's that difference? It's 0.013. 3 times 0.013 is 0.039. Add 2, you get 2.039. F of 2.013 is about 2.039. And we did that by hand. That's it. That's the practice exam. There's an exam tomorrow, if you didn't hear. Tomorrow's Friday. The exam's from 2 to 4. There's information posted. You probably want to email me before the exam. How come? Go look at that information that's posted. It gives you all the information. Hey, don't cheat on this exam. You're not allowed to use the internet for stuff. It's obviouser than you think when you are using the internet to do this stuff. I don't mind flunking students who I catch cheating, so let's not mess around with that. I'll have an exam up for you tomorrow. Do you have questions? Send me an email, or send me a text, or use the group text. Do whatever you want, but contact me if you have questions. I haven't heard very much from any of you guys. I have no idea how you're doing, so if you're having trouble, let me know. I wouldn't know. See you around.